Hello everyone. The topic that we will learn today might not just be important for your exam, but also in your life. It's called security, privacy, and data integrity. My name is James. I'm a computer science graduate turned teacher. And in this video, these are the following topics that we are going to go through. We're going to learn what is data integrity, privacy, and security, and what are some of the possible threats that your computer could encounter, and followed by what are some of the measures we can take to prevent these threats from happening. Let's look into what is data integrity. I will read out the definition first. It refers to the accuracy, consistency, and reliability of data throughout its life cycle, ensuring that it remains unaltered and reliable from creation to deletion. So in short, data integrity ensures that the data is indeed correct. This is important. For example, in your bank account, let's say you have $10,000. You want the data that is on the bank system to be exactly 10,000 when it comes to your balance. You don't want, let's say, it appears to be 1,000. Data integrity ensures that the data is correct. Second, data privacy. It refers to the protection of sensitive or personal information from unauthorized access, use, or disclosure, ensuring that individuals have control over how the data is collected, stored, and shared by organizations or entities. For example, if you have an Instagram page, you might have seen this before. Sometimes they say the private account is private. This is a form of data privacy in which you, as the user of the software, decide how you want your data to be shared. In order to enforce this, government have imposed this thing called the data protection law. They are legal regulations that govern how organizations collect, process, store, and share individual personal data. You will be surprised at how much data they actually collect about you, including how long you watch a short video, what likes you have given, what posts you commented the most. So by having data protection law, they ensure that the organizations only use data for purposes understood and agreed by the individual. This is why every time you use a software, they ask you to sign the term and condition, which we just agree anyway. It requires organizations to guarantee the confidentiality and consistency of this data. It also serves as a deterrent to prevent this company from selling your data to unknown people. Data security, unlike privacy, is about how to protect the data that you store from unauthorized access, corruption, or theft. System security guarantees that systems remain capable of performing the required tasks for users, with access limited to authorized personnel only. Not everyone should be able to see your data. However, ensuring data security does not itself guarantee either data integrity or data privacy. You might be able to secure your data, protect it, but you might not be able to make sure that the data that you are protecting is correct. So this is what this sentence is talking about. Let's look at some threats on the networks and also the internet. We are living in a multi-connected networks today. There are billions of computers connected together. So one possible threat is that some hackers within this network try to gain access to your computer system. The other type of threat is malware. Malware refers to malicious software, bad software, designed to disrupt, damage, or gain unauthorized access to a computer system or network. And there are many types of malware here, and this is what they do. Virus and worm, they are self-replicating, meaning once you download them and run them, they might duplicate so many files, and eventually your computer will just go into jamming mode. So it damages computer programs and files. That's for virus. And worm, they can spread through network, exploiting vulnerabilities. The type of malware, logic bomb, malicious code triggering on specific condition, causing damage. Trojan horse, disguised as legitimate software, meaning they appear to be like a good software, allowing unauthorized access. Spyware, as explained by the name, it spies on you without your consent, often for advertising. Bot, automated software performing repetitive tasks, often for malicious purpose. phishing, if you look at this diagram here, fraudulent attempt to obtain sensitive information through deceptive communication. For example, they can pretend to be a PayPal customer service provider, and they send you an email to ask you to log into your PayPal account. With that purpose is to get your information like your username and passcode, and that's what phishing do. Another thing is pharming, very similar, but it doesn't involve email, which means they direct you to a fake website. For instance, you are accessing your bank website, so they will design another website that look exactly like your bank website and lead you to that website to insert your personal details. So that's how they steal your data. Keylogger, software recording keystroke, capturing sensitive data and password, basically recording every single stroke you type on your keyboard. So these are some malicious software, and you can see how dangerous they can be. So the third type of threat could be resulting from us, what we do. Something that involves malware is that we click on suspicious email attachment or link. And sometimes, if you're not careful, you would have run the malware on your computer. Downloading files from untrusted sources, visiting unsecure or malicious website. So these are threats relating to malware. Some of the things which I'm personally guilty of, the use of weak password. When the second one, when a user failed to identify a phishing or pharming attempt, meaning we are directed to a fake website, but we don't know. So this is some vulnerability from our site as a user. So what are something that we can do to protect our computer? So there are a few steps. Disaster recovery, like floods and earthquake necessity continuing plan to ensure uninterrupted operation. So this is when you need to have a backup plan. So if you store all your data here, and when disaster happen, and all your data will be lost. But if you store the exact replica in another area that is safe, then you might be able to recover the website. This is called disaster recovery. And the site that is used as a backup is usually what we call a hot site. Second thing, safe system update. Due to continuous operations, system update require testing. Running original and updated system for a currently ensures uninterrupted service. So since the threat is constantly evolving, your defense might also need to evolve. This is when system software comes in. The third thing, user authentication, which is a way we can do to protect computer system. The purpose is to verify that the person accessing the computer is the owner of the computer, or at least it has access to it. And the three ways to authenticate a user: use a password, biometric like Face ID or fingerprint recognition, or even a security token like the one Google will send you every time you log into a new computer. The fourth one is just good practice. If you want to protect your computer, make sure you don't switch on when you're not there. Preventing observation during computer access and avoiding written login details. Backup data regularly and securely. Next one is a firewall. A firewall can be software or hardware based. It controls incoming and outgoing data, meaning everything you download, view, access will be going through this firewall to be checked based on predetermined security rules. So it can be hardware or software. Basically, it protects any unwanted data from coming into your computer. Digital signature is crucial for ensuring data integrity and authentication. But this is a topic that we'll discuss in chapter 21. This is just a preview on what we can do to protect our computer. Antivirus software, this is self-explanatory. It regularly scan, detect, prevents, and remove malicious software and threats from computer system. So these are some solutions we can use to protect our computer. Look, these are not just important for your exam, but I think it's important for everyone to know. Next, what are some measures we can take to protect our data instead. Now it's data. Some possible causes of accidental loss of data is that your disk got corrupted, destroyed, system crashes, the file is erased or overwritten by mistake, location of the file is forgotten. Some solution, recovering from data loss. Let's say there's a disaster. How do you recover? Is that you have a backup program. So what a backup software do is that it automates the process of creating copies of data file and enabling scheduled backup. It can be daily, weekly, or monthly to protect against data loss of system software. For safety purposes, the backup disk will be stored away from the system in a fireproof and flood-proof location. To ensure accurate data backup, a backup program temporarily halt file modification during copying, while simultaneously recording changes elsewhere in the system caused by ongoing use. Another function is called disk mirroring. Mirror means I copy exactly the same thing. Data storage technique that duplicate the data from one disk to another in real time, ensuring redundancy and immediate accessibility in case of primary disk failures. Restricting access to data by how you can restrict someone from using your data. One thing that you can do is to establish an authorization policy. It outlines the rules and guidelines determining the access level and permission granted to user or entities within a system or organization. An example that I'm giving you here is the system in an ICT lab. So the school might give different permission to the teachers. Let's say they can install something, whereas they can access some data file, whereas the students are only limited to using certain feature or access certain data. All right, this is how you restrict access to data by setting different levels of admission. Protecting data content. Data can be unreadable if the stored data is encrypted, meaning you encrypt the data so that even if a hacker got your data, they can't understand it because it will be very gibberish. Something we'll talk more about in chapter 21. Last but not least, let's look into data validation and verification technique. How do we ensure that the data we got is correct? So more on the other side, I created this Google form here that shows you the different check you can do, validation check you can do when taking data from other people. The first check is called present check. Let's say you created this Google form. If you don't want an anonymous response, you can do a presence check that requires them to at least write something. The next thing is format check. Let's say you are taking a date. You can make sure that they give you a proper date format instead of something that is unreadable. Range check. Look, in this example, your math result can be 0 to 100 only. So if a user accidentally key in a wrong value, the data will not be accepted because it's not in the range. This is what range check do. Length check. Let's say in Malaysia, the typical phone number is around 10 to 12 length. I don't remember, but if you want to ensure that they enter a correct phone number, you can do a length check to make sure it is at least 10 characters. Limit check, basically limit what is the number that the user can give. Type check, so in this case it's self-explanatory. It must be a number. That's validation, the 6 validation methods. So let's look into what a verification is. It is a process of confirming the accuracy and correctness of data entered into the system, which means that the data that we are collecting is exactly the same as what the user intend to enter. First method is double entry, something that we are very familiar with. They ask you to key in 2 times to make sure that you're keying in what you intend to carry. Second one is visual check. Basically just check with your eyes. Great. Check digit is another check that you can do to ensure validation, which is typically used in barcode. So the check digit here is usually calculated using a bunch of other numbers. So if there is a data entry error when it comes to entering barcode, the check digit will help to identify it. So this is what check digit do. Last but not least, verification during data transfer, which means if you are transferring data from your side to the other people's side, how can you ensure that, how can the receiver ensure that the data it received is exactly the same as the data that is sent? I will be talking about these three methods: parity check, checksum, and parity block check. And only the parity block check can identify the exact position of an arrow. Let me explain. So how parity check work is that they add an additional bit to a binary code to ensure that the total number of ones in the code, including the additional bit, is either even or odd. So parity check, there are two types. You are either using an even parity method or an odd parity method. Both ways work. So suppose a 7-bit code is to be sent. How can one verify that no error has occurred during its transmission? Assuming that I'm using even parity. This means that the byte that I send should have an even number of ones. So using this fact, I know what to set my parity bit on. So in this case, I will set my parity bit as 0 to make sure that in this byte, there are only 1, 2, 3, 4 number of ones. All right. So when this data is sent to the receiver, now if any error has occurred, it will be reviewed. For example, in this byte here, if I were to change this bit from 1 to 0, and the receiver knows that even parity is used, what it will do is that it will check, is there an even number of ones here? And it will count 1, 2, 3. So there are only 3 ones, but it's using even parity. Therefore, the receiver will know an error has occurred during the transmission process. So this is how a parity bit in a parity check will help detect an error. But of course, parity check is unable to detect an even number of bits error. For example, if 2 bits are corrupted, and if you calculate the number of 1, it will still be an even number. So parity check, one of the limitations is that it cannot detect when an even number of bits have been changed. This is when checksum comes into play. So a checksum is a more secure method. It's a numerical value calculated from a data packet for the purpose of error detection, ensuring the integrity of the transmitted data. For example, this is the data that I'm trying to send. And what checksum will do is that based on the data sent, a chunk of data, they will undergo an algorithm. So algorithm is a series of steps to get a solution. Let's say my algorithm is to sum all the value up. And if you sum them all up, it will be 150. So this number here will be transmitted along with the data. So what if there is an error that happened here, which is it changes from 65 to 1. Now, at the receiver side, if they were to do the calculation again, they will get 86 instead. But then the checksum value that is received is 150. And this shows that an error has occurred. So this is how a checksum like that will detect an error. Just for your information, the algorithm doesn't have to be sum all the numbers up. It can be summing everything up, multiply by 2, divide by 4, and get the remainder. So it can be any algorithm, but just know that there is a series of steps that it goes through to get the value, and then it will cross-check it at the receiving end. Last but not least, this is the most powerful validation check for data transfer. Because the previous two methods, if an error has occurred, what we know is just, alright, an error has occurred, but you might not know at which part an error has occurred. But parity block check tells you exactly where the error occurred. For example, you are transferring a chunk of data here. So by using the parity check, you can generate the parity bit for each byte. What's so special about this is that they generate another bit by using the column. So let's say I'm using even parity. The column here has to have an even number of ones. So this is how the parity bit is being assigned here. So as you can see, every single column has an even number of one. So what's so special about this, you might ask? So now every row has an even number of 1, and every column has an even number of 1. So if an error has occurred, look, if I change 1 to 0 here, and what happened is that, all right, I found that on row number 4, this row doesn't have an even number of 1. And coincidentally, the column here also doesn't have an even number of 1. So by drawing this imaginary line here, and the intersection of it will show you that which is the bit that has been corrupted. So this is how parity block check not only detect an error, it detects the location of an error. In this case, it will be useful so that the system can just correct it. So this is parity block check, and that is also the last topic for our video today. That's all about security in the computer system. Thank you so much for watching. If you have any question, just leave it in the comment section and I'll try to answer it. Thank you.